Alright guys, so now we are going to try to do some problem on the section 2.3 and it's going to be page 120. Alright, so in this page 120, let's try to do the problem number 9, and it's going to remind us some of the transformation we've seen in the previous section 2.2. So problem number 9, we're having y equal x, y2 equal x plus 3, and y3 equal x minus 3. So if I want to graph, let me have the same way of representing things. So problem number 9. If I want to graph y equal x, I know that y equal x has a slope m equal 1 and a y-intercept when x equals 0. Well, obviously, the value of my function when x equals 0, f of 0, equals 0. And basically, I know from the beginning that it's a line going through my origin. Now, if I want to graph y equal x plus 3, which is, so the first one was y1. If I want to graph y2, y equal x plus 3, that remind me that basically y2 is equal to y1 plus 3. And so basically I got a function f of x equal another function g of x plus 3, which is basically f of x equal g of x plus k. And I know when I'm dealing with a plus k, I have to go up of k unit. Okay, so every single point of this line, including the origin, will go up plus 3. So 1, 2, 3. Now, if I take in consideration that I've learned in chapter 1, I could also say that the slope equal 1, the y-intercept is 0, 3. So from the point 0, 3, which is the same point, the point that I've already marked right here, I need to go up 1, right 1, and so my line is like that. And I can clearly see that I went up of 3 units. Now if I take a look at the other one, and if I take a look at the other one, which is y equal y3 equal, oops, I was already ahead of what I want to tell you, x minus 3. This reminds me basically that y3 equal y1 minus 3, which is about f of x equal g of x minus k, and that means I will have to go down of k unit from the first, from y1. So y1 is going to go down of 3 units, 1, 2, 3, and I'm going to have a line like this. I try to have all these lines parallel to each other. Why? Because if you take a look at the slope of this line, again, the slope of this line equal 1, and the y-intercept is 0, negative 3. This is where you have your y-intercept. Okay? So is it normal that these lines are parallel to each other? Yes, because we are dealing with exactly the same slope. And we went down of 3 units. Okay? All right, so now let's try to do the problem number 13. So same idea on this problem number 13. Problem number 13, first of all, I am going to graph y1. y1 is square root of x, is equal to square root of x. So I know square root of x is going to be something like this. Now if I want to graph y2, y2 is square root of x plus 6. Okay? And I can clearly see that this function, if I call y1 equal g of x, y2, it is f of x equal g of x plus 6. And that reminds me f of x equal g of x plus k. And I know when it's a x plus k, I need to go to the left of k unit. So I know that x square root of x plus 6, it is the first square root of x moving to the left of 6 units. 3, 4, 5, and 6. And I'm dealing with square root of x plus 6. Same idea if you instead to have square root of x plus 6, we are having square root y3 equal square root of x minus 6. That reminds you f of x equal g of x minus 6, which is f of x equal g of x minus k. And I know that is a shift to the right of k unit. So 1, 2, 3, 4, 5, 6. This is y3. Now, if I look at the problem number 14, on the problem number 14, it's a little bit different because problem number 14, now we have three functions. Function number 1 is absolute value of x. Function number 2 is 2 times absolute value of x. And function number 3 is 2.5 absolute value of x. Okay, so we can graph the first function. The first function, y1, the axis y, the axis x, and I know that is the basic function absolute value of x, y1. Now, I must take a look at y2. When I study y2, I can see that it's 2 times 2 multiply 2 times absolute value of x. That reminds me that if I call absolute value of x, y1 equal g of x, y2 is a function of x equal to 2 times g of x. And if it's equal to 2 times g of x, that reminds me, it looks like f of x equals c g of x, with a c greater than 1. And that means you are dealing with a vertical stretch. All right, vertical stretch. So, what does that mean? That means that your new graph, if I represent the graph right there, g of x, now if I want to have 2 times g of x, I'm going to have that. Okay? And every single point has been on the value of f multiplied by 2. Now, if I want to do y3, if I want to do y3, that was absolute value of x. We end up to have, all right, this color. The vertical stretch with 2 times absolute value of x. Obviously, if I'm looking for 2.5, it's going to be stretched even more, and that's 2.5 absolute value of x. So now let's add another example to this problem by trying to represent y4, which is going to be 1/2 of absolute value of x. That reminds me f of x equals cg of x, but this time c is in between 0 and 1. And that means that I'm supposed to have a vertical shrink. Okay? So if I graph this being absolute value of x with a vertical shrink, the representation is going to be this one, 1/2 of absolute value of x. If I take a look at the value and the coordinate of this point right here on absolute value of x, let's imagine that you are at x equal 4. Okay, and so you are at y equal 4. All right, it's not the same scale on the axis, but that's all right. Let's imagine that you have x equal 4, absolute value of 4 equal 4. When you are dealing with 1/2 of x, you end up to have x equal 4, but this time you are 2, right? If I take a look at the point in red, I'm having, when x equals 4, I'm having absolute value of 4 for the value of f of 4, and it's going to be equal to 4. So I'm dealing with 4, 4. But if I'm looking at the orange point now, corresponding to the function 1/2 of the absolute value of x, I'm doing the same idea. X is still 4, but this time I'm dealing with 1/2 of absolute value of 4, which corresponds to the value of my function when x equals 4, and 1/2 of absolute value of 4 is going to be equal to 2, 4 divided by 2. Oops, I went on a little bit much right there. Okay, so please guys, you must pay attention and you must know what you are supposed to know. So I'm just going to recap. If you have a function f of x and this function is equal to c, a constant, a number, multiplying by another function, if c is greater than 1, you have a vertical stretch. If c is between 0 and 1, you got a vertical shrink. All right, so now let me try to do another problem in another video.